Hey guys, today we're going to do kth smallest element in a binary search tree. Given a binary search tree, write a function kth smallest to find the kth smallest element in it. So you may assume k is always valid, and let's look at the examples. Given this tree, binary search tree, right? 3, 1, 2, 4, right? Get the smallest element. In this case, we know just by glancing at the tree that the smallest element is 1. In this next example, we want the third smallest element. And so in this case, the answer is 3. So go 1, 2, 3, boom. Okay, so what we know about binary search trees is that if you do an in-order traversal, you will get the sorted values in that tree. And so although there probably are optimizations to kind of end early to get the kth smallest element in the binary search tree, I imagine that the reason we want the k smallest element in the binary search tree is because we want to do that repeatedly. And so the way I'm going to solve this problem is by basically doing in-order traversal and then picking the k minus 1th index of that sorted values array. Now, just to say in advance, we could just only get the first 3 or the first k, and then once we get to k, we kind of stop. And that should be an easy modification to the algorithm. So let me just actually reset to default code definition. Yes, please. Okay, so here we have a kth smallest, we're given a root and a k. So first thing I'm going to do is call this get the sorted binary search tree values, right? And we're going to just call a depth first search in order traversal. In order traverse on the root, and we'll pass it the initial array, and then here we'll return sorted BST values of k minus 1. And we know that k is going to be in bounds because the note here says it's always valid. So let's just do the in-order traversal. We'll say in-order traverse, it's going to take self, root, and the sorted BST values so far, right? So if not root, we want to return our sorted BST values. Otherwise, we do self.inOrder traverse of the root.left, right? Because we want to go left all the way down. That's the smallest value. And the sorted BST values, right? We'll do the same on the right side. And then the way the in-order traversal works is we're going to actually, first go left, figure all that out, and eventually we're going to get back to our root value. We want to add that to our sorted array first before going down the right path. So here we'll do sorted BST values dot append root dot val. And then at the end of this, if we've gone all the way through, we can return sorted BST values. So now, like I mentioned earlier, we could keep a counter here, or every time we add a value, check to see the length of our sorted BST values, if it's equal to k. If it's equal to k, we return early and, bang, we got our answer. But I like to have this full in-order traversal, full sorted order array. That way we can check the k smallest element as many times as we want with as many different k's as we want and not have to reprocess the binary search tree. So I actually have not run this, so let's see if it works. Cool. And if I give it maybe the third smallest, cool. Yeah, thanks for watching. That was fairly simple. We have to basically iterate in this particular solution. We have to go through all the nodes to find the kth smallest element. However, if we only need to do this operation once, we should probably end early. So return early the kth smallest value. So it's important to ask your interviewer what the use case of this function is, so you can kind of optimize for that. I actually totally forgot to actually submit the code. So here we go. I submitted it a few seconds ago and got this result. Thank you.